Assalamu alaikum again. Today I will discuss about a problem which is from Codeforces around 871 D4. Problem name is Don't Blame Me. So in this problem, if I read this statement, they are given an array of n integers. They are given an array of n integers, and you have to count the number of non-empty subsequences such that the bitwise end of these subsequence elements having exactly k bit set. That means after if you let's say this is your uh, 1 2 3 0 array, then you can your subsequence is 1 1 2 uh, 1 3, then 1 2 1 3, then 2 3, then 1 2 3, which is at 1 2 3 4 5. It should be 7 uh, of here 2 and 3. So this is your total subsequences. If you bitwise end them, then bitwise end of this element having exactly k set bit. That means 1 2 3, if you bitwise on them, 1 1 2 1 0 1 1, then it was on 0, and that is 0, so it will be 0. So in this case, the total number of set bit is 0. So in that case, k equal to 0, right? If your subset is 2 and 3, that means 1 0 and 1 1, then your it will be 1 and it will be 0. So total number of set bit equal to 1, so k equal to 1, right? So like that, you are given an n and k. That means uh, required number of set bit in bitwise end of in your sequences, right? And array element. Okay. Uh, so n less than equal to 2 into 10 to the power 5. Okay. K less than equal 6. That means you have your final bitwise end consists of only 6 set bits, right? Maximum set bit might be 6. So so for this, we are we are we are we're interested to know the array element size. So array element is less than equal 63. That means 63 to 0, that means 0 0 0 0 0 0 0 0 to 1 1 1 1 1 1, which is 63. This is 0, right? So your k will be at most 6 set bit, right? That means k cannot your final answer cannot get up than this, right? Because if your array element is only 6 bit, right? So you cannot mm, you cannot arrange a 6 set bit in final array which bit is 7, right? Like I am what I am trying to say that, see, you cannot do this 1 2 3 3 1 2 3 4 5 6 7 2 3 4 5 6 7. You cannot do this, right? Here is also 6 bit set, right? But it is not possible. Why? Because your array element is only 6 bit, right? So it is not possible. Okay. So I think problem is treatment are clear. So let us try. Let's take a example to understand the problem. So let's do it. So okay. So in first sample, you are given five element one 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 one, right, and k equal one. That means your bitwise end should be exactly one k set bit. All right. So we know that k set bit means our element is 1111. So when our exactly bit will be set for this element, see, if I take this as a subsequence, then this is only one, which is only one bit is set, which is correct. That means this is answer. This might be answer. This might be answer. This might be answer. This also might be answer, and this. So total answer for just taking one element is five, right? One, two, three, four, five, right? Now, if I say to take two element, what can I do? So my one is one, two, three, four, five, one, and I can choose any two one, right? Because one is also bitwise and is one, right? So it will be five C two, right? Then if I take three element, five C three, then if I take four element, five C four, and if I take five element, which is five C five, and this five plus five C two means 4 into 5 20 divided by 2 10, it is also 10, plus 5 plus 1. So this is 20, 30, 31, which is answer, right? All right, I think you get the point, or you have understand the statement and test case. So how can we solve it? So after seeing this k less than equal 6, in contest time uh, my thought was like, okay, if my k equal 1, see this sample, right? If my k equal 1, so if I have only, let's say my element is only 3 bit, right? Only 3 bit, forget about 6 bit. Let's assume that your element is only 3 bit, okay? Then when 3 bit and total element is like, let's say these are element, right? 101, 101, 111, 100, and 010, right? Just assume that they are 3 bits. All right. So I have told you that uk is only 1. Okay. If k is 1, that means for 3 bit your answer might be 100, right? Your final bitwise end may be 100 or 010 or 001. Makes sense? Because your final answer might be one of them, because all of this configuration having only one set bit, right? So after seeing k's element is very low, so my mind hit this, so I have thought like that. Okay. So so now I know that my k is this or this, right? So I will find this at first, which is 1 2 and 4, 1 2 and 4. So I will find for 1. That means I will check all the elements which bitwise end is 1, right? So how can I do this? Easily I can do this using dp or 01 knapsack, that uh, which elements between and is one. So okay, so here is you, if you can see, mm, so I can't make any subsequence which value is 1. So yeah, so for 2 I can make this, I can take this 10 and this 11, right, this and this, okay, which is 111 and 10, which is equal to this 2, right, this, all right. So I can easily do this by using dynamic programming, but e- I have uh, in my solution I have tried to find previously find k, that means uh, which I have find a value which set bit is k, number of set bit is k. So for this reason, if my k equal 1, then for array element 6 bit, 3 4 5 6 bit, my k will be 1, here 1, here mid 1, here mid 1, here mid 1, here mid 1. So total 6 configuration, there may be 6 configuration, 6 configuration for k equal to 1, and for k equal to 2, how many configuration will be there. So let's say, right, for k equal to 2, what how many configuration will be in there. See, my array element, array is maximum 6 bit. So if I fix this to the 1, then how many AOS I can fill with this segment by exactly 1 1. So it is 5c1, 5c1, which is 5. Then if I fix this, then 4, then 3, then 2, then 1, which is 15. For k equal to 2, I have 15 configuration. For k equal to 3, for k equal to 3, I have, if I take this, if I fix this, then rest of I am leave with 2, I am left with 2 elements, 2 1. So 5c2, which is 10, 10, then 6, then 3, then 1, which is 20, right. For k equal to 4, which is again which 15, k equal to 5, it will be again how 5, 5, yeah, 5, and then k equal to 6, it will be only one configuration, which is 1 1 1 1, right. And k equal to 0, there is only one configuration, 0 0 0 0 0 0 0 0 0, right. So I I think like that, right. So first of all, I have what I have done, that I have run a loop from I equal 0 to I less than 64, right. And I have checked if number of set bit of I equal to k, right. Number of set bit is equal to k, then my value is this I, right. So then I have run my dp, which is a function, then if my answer is answer, then answer plus is equal f of f is a function f of from which from my state is f of uh, 0 to f of 0 and my n below at end, right? 0 means current index, so 0 to, so what will be end initially? So my end, every element, every subsequence is I will interested to find every subsequence end. So initially I should all the bit is equal to 1, right? So that's why my end initially will be 63, right? So I have run this this way my function. So if I write the main my function f of 0 to 063, where 0 is index of array, right? So what can I do? See, initially I have taken an variable a equals 0, that means 0 a os. So a equal f of I plus 1, this is I and this is end, end. So f of I plus 1, and that means I will take this element, right? Ith element, I will take this ith element. So next my end will be end bitwise end with array of I, right? So my end will be end bitwise end of array of I, right? Like this. And if I am not interested to take it, this ith element, so I will just leave it as it is. So I will just move I plus 1 and end will be um, like previous end, right? So my base case, what will be my base case? So I plus 1. So if my I is equal n, then means I have reached my last position. So my iteration is over there, and I will check if end equal value, right? That means I am finding this value, right? I, my, so if end is value, then I will return 1, otherwise return 0, right? So like this I have implemented it, but there is a problem. See, so this is a dynamic programming, right? So I have to memorize it. So I have taken a memorization table which is mem, which makes n, makes n 2 into 10 to the power 5 and 64, because my n cannot get other than 63. So it is 64, max n into 64. Initially all the element is minus 1, that means mem set equal minus 1. So I have memoized like that. If mem of I and end not equals to minus 1, then return it, otherwise return from this line, right? So there is a problem. What is the problem? See, I have not I am solving like I have fixed my I, right? I have fixed my value, right? So for every value I have to I have to uh, redeclare of memorization table, right? So for starting every state, it means for every value I have to redeclare it memorization of uh, uh, or you can say that mem set of memorization table, right? Minus 1. But there is a problem. What is the problem? So the problem is there that my table is memorization table is 2 into 10 to the power 5 into 64, right? And for I will do this, I will run this loop in 64 times, right? So my complexity will be like, so my complexity will be 64 into 2 into 10 to the power 5 into 64 into 10 to the power 4, which is test case. So this is greater than 10 to the power 9, right? So it should not be, yeah, accepted, right? So then I am thinking about how can I solve it. How can I solve it? So few um, after few times, I have thinking that okay, I will not iterate over every element of every array element, right? That means 0, 1, 2, array of 1, array 2, array 3, and array of n minus 1, right? I will not do this. What I can do this, my array element is only 0 to 63, right? So for every value which was there for every value, okay, I have as previously I have taken my value equal I, that means I have fixed it, okay. So now I have think about that, okay, I cannot iterate over every element of array. I will just iterate from 0 to 63, right? Let's assume that my value is 4. Let's assume that my value is 4. So there is a answer of, okay, 4, 5 and 6, right? 4, 5 and 6, because 100 is 4 and 105, 110 is, so 100 it is equal to value, right? So it is, because and is 4 and value is also 4, so this is my answer, this might be my answer. So what I have done, if I have count how many number 4 are there in array. So if there are 3 array, 3 4 and 2 5 and let's say 2 6, right? So how many configuration is there? So these 3/4 may, I can take them NC 3C1 or plus 3C2 plus 3C3, right? For this 4, so it is 2 to the power 3 minus 1. It is like NC1 plus NC2 plus NC3 plus NC4 plus NCN is equal to the power n minus 1. So you can Google it and you will find the proof of that. So for this, I have this, okay, I have think, okay, uh, if I have 3 4, so I have 2 to the power 3 minus 1 configuration into how many 5, 2 times 5, so 2 to the power 2 minus 1 into 2 to the power 2 minus 1. Their multiplication will be my total number of towers to become my bit was and equal to value, it is 4, right? I have done this, okay. So for this I have changed my function like this, okay. I equal to 0 to, I will iterate 0 to 63 only, right? And my n value equal to as previous, equal to as previous, that means it will be same as previous. So now my a equal to will be big big mod of 2 to the power, that means I want to take uh, I 0 to 63. I want to take I as I want to include I in my answer, so it will be big mod 2 to the power I minus 1, right, into f of I plus 1, and my end equal to will be, and it was the end of this I, right? And if I am not interested to take it, so just leave it as it is, f of I plus 1, and just end with this. So my memorization for this, my memorization table will be mem I and n, so which is 64 and which is also 64, so my memorization is like 64 into 64, so total complexity will be, okay, my total complexity will be 64 for the first loop, which is value to find value, into for memorization table 64 into 64, and for test case 10 to the power 4, which is not greater than 10 to the power 9, right, which is less than 10 to the power 9. If I show you 64 into 64 into 64 into 10 to the power 4, all right, okay, there is a problem. See, my memorization is 64 into 64, that's no problem, but for my value, right, to find my value is this, how many time it will generate value, maximum 20. Why? Because for k equal 3 it is 20 times, right, so it is 20, right, into 10 to the power 4, so it is like this, it is 10 to the power 8, or 8 into 10 to the power 8. It has passed, but I am not sure enough that it will AC. But my solution, first solution was okay, but let's see after system testing what is happened there. So okay, now you are okay. We are now okay. Let me show you the code. At first, I have declared n and k and array and our value, right? So in solve function, I have taken my n and k, and I have taken array count, which will count all the element from 0 to 63 of in the array, right? So I have taken an answer initially, which is 0, and for 6 k equals 6, that means uh, all the bit are set, so there is only one case, which is 1111 so which is 63, so I have just okay 2 to the power, how many 63 there, then minus 1 is like this, 2 to the power number of 63, so count of 63, 2 to the power 6, count of 63 minus 1, right, so I've just done this, alright. then then I have iterated from 0 to 63, and I have checked number of set bit, and I have checked it using built-in function, and is equal k, then I have set value equal I, and memorization and the set memorization table is equal to minus 1, and I have run my f of function from 0 to 63, and my end is initially 63. So if I am in I equal 64, that means I have done with 0 to 63. If end is equal to my value, then return 1 or return 0. And in here a equal big of count of I. What is that means? Which is big of, which will be big mod of 2 to the power count of I, right? Minus 1. But if I use this for here, there is a additional time limit added, which is log n, which is not good for me because it is already tight. uh, so what I have done this, I have made a function which calculate initially big of I, which is big of 1 is equal to the power 1 minus 1, big of 2 equal to the power 2 minus 1, and big of I equal 2 to the power I minus 1. That means I have pre-calculated for how count, for how much count, what will be added in my answer. So this is big of count of I, right, into y plus 1, and then and rest of is as it is. So yeah, that is accepted till now, because system testing is not finished. So let's see what happen in future. So yeah, that is the solution for this problem. Thank you. Tata. Assalamu alaikum.